Hey, welcome back to Fat Mama Physics. This is a continuation of 5.3 horizontal vertical lines, in which this one we're just going to look at a different form of an equation in which just to get you more exposure. But what happens if you do get an equation that's in this format? How would you graph it, and basically how will you go about graphing it? Notice that beside every example there is a table, a space for you to record down possible values for you to graph on the side over here. So this table is giving us a value here, which is 0. And this is the equation, x plus y equals to 6. So how do we generate a table of values? Let's start with the 0 because it's given to us. What that means is if I plug x is equal to 0, I'm going to get a value for y. It's kind of like a function or like a computer. You have an input, and then the other value is like the output. X is like your input, y is like your output. Dependent, independent variable, dependent variable. Okay, so let's go here. If x is 0, my y is going to be 6. And it looks like based on the where they position the 0 in this question, it seems like we want to kind of go less than 0, which is probably going to be -1. So let's try -1 here. If my x is -1, then I get -1 plus y is equal to 6. Moving -1 to the other side becomes plus. I get y is equal to 7. So what happens if I have -2? If I have -2, then I have -2 plus y is equal to 6. So if I move -2 over, that becomes +2. Y is equal to 8. Now, as we move down, however, let's going from 0, and the other side of 0 is going to be our +1. If I put +1 in the equation, I get 1 plus y is equal to 6. So moving y over, I get y is equal to 6 minus 1, which is 5. Ooh, the pattern is pretty consistent. So now we have 2. If x is equal to 2, I get 2 plus y is equal to 6. Moving 2 over, I get 6 minus 2, which is 4 for y. Okay, so there we go. We generate a table of values. So notice what we did was that we just plugged in random numbers for x. Well, I mean, not completely random. We plugged in numbers for x. The equation spits out a value for y, and that helps us generate a bunch of values we can use to coordinates that we can use to plot on our graph. So here, I'm just going to put a note here. One box equals to 1 unit. Okay, so basically I am just going to normally I would label a graph, but just to save space, save time in this video, I'm just going to put a note up here, and assuming all of my boxes are going to be 1 unit for my x, 1 unit for my y, etc. So for example, in my first one, I get -2 is here, and which is for my x value. My y is going to be my going up, and that's going to be 1, 2, 3, 4, 5, 6, 7, 8. However, it's going to be up here. Okay, so that's my first step, first point. Then I have -1. -1 is going to be here. That's going to be 7, which is going to be here. 0 is going to be 6. 1, 2, 3, 4, 5, 6. I think it's just going to keep going. 1 is 5. 1, 2, 3, 4, 5. And then 4 for 2. Okay, so here is my data points. And since this is a graph, this is a function in which is continuous, we do need to draw a straight line as best as we could. Okay, you get the idea. Okay, so we're going to do the same thing for the next couple of graphs here. There's actually B and C. So what I'll do is I will ask us to maybe I'll pause the video. We'll do one at a time. So I'll ask you to pause the video. You're going to do this question, and I'll ask you to pause again to do the next one. If you don't care and you feel really good about it, just look at the solutions at the end, okay? So try B by yourself. For this particular graph, treat every box as 1 space, as 1 unit, and you may go ahead. Good time to pause video. All right, so first of all, we're going to generate a table full of values. So if I put 0 into x, I get -y is equal to 6. Or if I put the negative sign on the other side by multiplying both sides by -1, I get y is equal to -6. seems like this table wants us to move into the negative x's. So if I get negative 1 for my x, I get negative 1 times 2, which is negative 2, minus y equals to 6. If I move negative 2 to the other side, ooh, that's going to be weird. Watch, this is going to be drawing an arrow. I get negative y is equal to 6 plus 2, because 2 becomes positive. That's 8. So y is equal to negative 8. Oof, that's a little ugly. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that might be the cap, but we'll see. Okay, x is equal to negative 2. So we get here, negative 2 times 2 is negative 4, minus y equals to 6. If I move negative 4 over, I get negative y is equal to 10. So y will be equal to negative 10. Let's do x is equal to 1 then. So 1 times 2 gives us 2 minus y equals to 6. Rearranging this, I move 2 to the other side, so 6 minus 2. Negative y is equal to 4, so y is equal to negative 4. What happens if x is 2? 2 times 2 equals to 4, minus y equals 6. Rearranging, I get negative y is equal to 6 minus 4, giving us 2. Therefore, y is equal to negative 2. Okay, so assuming every box is 1 unit, just like I labeled at the top of this page here, 1 box is 1 unit. Let's plot this one out. So at negative 2, x is equal to negative 2. I have negative 10 for y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So somewhere over here. Okay, negative 1 is going to be 8. I believe was 1, 2, 3, 4, 5, 6, 7, 8 over here. Okay, 0 is going to be negative 6. 1, 2, 3, 4, 5, 6. Okay, and 1 is negative 4. 1, 2, 3, 4. 2 is negative 2. 1, 2. Okay, here is my line. I draw a line through all of my dots as best as I can. And voila! There you go. There is my equation and my graph line. Okay, we have one more example. So if you'd like to pause the video now, try it out, and we will go over it together. Okay, so let's finish up the last example. Okay, again, it seems like they've given us the first one, which is 0. So 0 for x times 3 is still going to be 0. We're going to left with negative 2y. Oh, don't forget the negative there. Is equal to 6. Okay, so then if I divide both sides by negative 2, I get y is equal to negative 3 if I divide both sides by negative 2. Okay, so y is negative 3. Ooh, this is tricky numbers here. And I kind of want to try something, because notice on my axes here, I can go from 0 for x to negative 2 to negative 4. So I'm going to try negative 2, see what that gives us. So I get 3 times negative 2, that's going to be negative 6, minus 2y is equal to 6. Okay, I'm going to move negative 6 over, and that's going to give me, here, I'm going to zoom in. Okay, negative 6 moving over, that's going to be negative 2y is equal to 6 plus 6, which is 12. I get y. Okay, so then divide both sides by negative 2. I get y is equal to negative 6. Okay, so then going with this pattern, I'm going to choose negative 4 for my x. So negative 4 times 3 is negative 12. And then I get minus 2y is equal to 6. I move negative 12 to the other side. I get negative 2y is equal to 6 plus 12. That is 18. And then divide both sides by negative 2. I get y is equal to negative 9. Okay, going with our pattern seemingly looks pretty well. It's working. I'm going to use 2 and 4 instead for my values of x. So let's put 2 in. So I get 2 times 3, which is 6, minus 2y is equal to 6. Ooh, this looks pretty cool. Okay, so then I have 6 and 6 on both sides of my equation. They actually cancel out. I get negative 2y is equal to 0. And hey, if I take 0 and divide by anything, it's still going to be 0. So my y is just going to be 0. Yay! Life is easier. Okay, next up we have 3x. So I'm going to take 4 times 3x. That's going to be 12. Minus 2y is equal to 6. let's rearrange it because I'm going to get 12 on the other side, meaning 6 minus 12. So negative 2y is going to be 6 minus 12 is negative 6. Divide both sides by negative 2. I get negative 6 divided by negative 2. I get 3, positive 3. Phew! Okay, so we have our data tables. Now we can do some plotting. When my x is negative 4, which is over here, I have to go down negative 9. Go down 9 steps for y. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so somewhere here. Then negative 2 becomes negative 6. 1, 2, 3, 4, 5, 6. That's going to be right here. Notice that I'm going up by 2s instead of 1s. Okay, so next up we have 0. When my x is 0, my y is negative 3. 1, 2, 3 below the y-axis. And then if I have 2, which is x is equal to, I get 0 for my y. So that's just going to be right there where it's 0. Next up we have 4, and then that's going to give us a value of 3 for for y. So I go up 3, 1, 2, 3. That's going to be right there. That's a big line. So we draw a continuous line from there to all my other dots, and here we go. That is the last relationship that we have. Whew. Not bad, hey? Take a look at these lines, okay? Some of them look like they're sloping downwards. Some of them, they're sloping upwards. And that's going to be hopefully what you'll be looking at soon enough is the rate of change for these graphs and how they can be negative and positive. Okay, so here's kind of how you would tackle an equation and graphing it. But you might be thinking, if I have an equation, is there just like a straightforward way I could just take it and just graph it? Yes, there is. That is called the slope by intercept form, which, if you get a chance to learn that will be really helpful for you for the rest of the unit. But for grade 9, for our level, you may not need it, but it will be so useful. It's almost basically what I'm teaching you right now is going to be obsolete once you learn the slope by intercept form. Meaning you're not going to use this method almost at all when you do higher levels of math or even science and everything. This becomes obsolete. So if it's a starting point, and we're doing it just to get you to recognize patterns. But when it becomes to realistic situations, we don't really do this a lot. Okay, so I know it's like, why did I listen to this lesson? It's still important because it's still good for you to see patterns and to recognize patterns and to manipulate patterns. But it's definitely a starting point. Okay, that's what I'm saying. All right, so hopefully this video helped build up some understanding of how relation between equations and their graphs. Thank you for watching, and see you next time. Fat Mama Physics signing out.